Hey, good morning. I haven't done this in a long time, so I'm going to attempt to give you a brief rundown about what is this going to be about? This is going to be about preparing molar solutions, okay? So whenever we prepare a molar solution, we use a volumetric flask, all right? Let me draw you a picture of a volumetric flask. It's got a really long, thin neck, and it kind of bulges out here at the bottom, okay? And then there'll be a line here. And this line is the volume marker. Some volumetric flasks are 100 milliliters, 50 milliliters, 200 milliliters, 500 milliliters, 1,000 milliliters, 2,000 milliliters. So you can get all different volumes. The line here shows you where that particular volume is. So each flask only measures to one particular volume. Now, the way you make the solution depends on if you have a solid solute, all right, or if you have a liquid solute. If your solute is in solid form, then you must find the mass in terms of grams of solute to dissolve in the given amount of water. Oops, let's say in water, all right? So if your solute, what you're making your solution out of is a solid substance, then you're going to need to find the mass of that substance, and then you will dissolve that mass in water. For example, let's say I need to make 200 milliliters of I'm going to need to grab, excuse me. Let me grab a calculator real quick. Got one. And I see that I just made this better for you. Let's say that I'm going to make 200 milliliters of a 2.0 molar solution from NaCl, all right? NaCl is a salt, so it's going to come in a solid form. What will I do? I will do what we've just learned. I'll take my 200 milliliters. I'll say, okay, convert those milliliters to liters. And then my solution concentration, according to my molarity, states that for every 1 liter, I need 2.00 moles of solute. Well, I don't measure moles, I measure grams. So I will then say that every 1 mole is 58.44 grams. That's because my solute is NaCl, and that is the molar mass of NaCl. I'm then going to do the math. I have my handy dandy calculator. 200 times 2 times 58.44 equals. And then I will divide that by 1,000, and that tells me that I need 23.4 grams of NaCl. Okay, how will I make this solution? I will get my volumetric flask, all right? And I will first put my 23.44 grams of my solid in the flask. That will be my 23.4 grams of NaCl. Get the flask. This flask will be 200 milliliters because that's the volume of the solution I need. So the marking right here will be the 200 milliliter mark. Now, what do I need to add to this to make it a solution? I will now add water, and I will add water until my water reaches that 200 milliliter mark. I will then mix everything together, and I will have 200 milliliters of a 2.0 molar NaCl solution. So I had to get the mass of the salt to make that solution. If my solute is liquid, then I must be diluting. So I need the volume of solute that needs to be diluted. Okay? Well, lucky for us, there is a simple dilution equation. And our dilution equation is M1 times V1 equals M2 times V2. Initial molarity, initial volume, final molarity, final volume. Doesn't matter what your ones or your twos are as long as you have them appropriately paired. For example, I need to make 200 milliliters of a 6.0 molar solution. And what I have available to me is from an 8 molar solution, okay? So I'm going to plug it in so that this volume and this molarity go together. So my initial molarity will be 6.0 molar. My volume is 200 milliliters. It doesn't matter that my volume is in milliliters as long as they are the same on both sides. I will set that equal to my 8 molar, and then I will solve for the volume of it that I need. 6 times 200 equals, divided by 8 equals, and that gives me a volume of 150 milliliters. How would I make this solution? Well, I'm making a solution, so I would get my volumetric flask. All right? Because in this one, let's assume that this was an acid. It's often an acid that you're diluting. Whenever you are diluting an acid, the first thing you want to do is get your flask, appropriate volume, and you want to put some water in here, okay? It's like a buffer. It absorbs the heat when the acid mixes with the water, and it dilutes it if it were to spill. So I have a flask, I've put some water in it. I will now take my 150 milliliters of my strong concentrated acid, right? So that's the 150 milliliters of the 8 molar acid. I've added it to some water. I will then finish preparing my solution by adding enough water until once again I reach the 200 milliliter mark. All right, at this point, I have prepared 200 milliliters of a 6 molar HCl solution. That's how you make solutions, dependent on whether you have a solid solute or whether you have a liquid solute that is being diluted. We dissolve the solid solute by adding water till it gets to the volume point in our flask. We dilute a solute by adding water until it gets to the point. If we're diluting an acid, remember we always add acids to water. That's it. Thank you. Bye. Stop share. End.